This is part 2 for linear equations in chapter 1, section 1. And this video will cover solving for a specified variable, also called solving a literal equation. And then we'll also talk about the simple interest formula as well as the future or maturity value formula. Please make sure you take notes in your notebooks and bring them with you to class tomorrow on Monday. Alright, this gives us the formula for a simple interest, calculating that, and I want to point out the different parts. I stands for the interest, simple interest, and usually that's the one you're trying to find. P stands for the amount that is borrowed or sometimes invested. Principal is what it refers to. R is the variable for the interest rate, and it's usually given a percentage, so we'll have to take that percentage and make it into a decimal. And T is the variable for time in years. Make sure that if they tell you they've invested it for 18 months, then you would calculate that as 1.5 for T, because we have to put that in year format. Alright, for this example, we're actually going to take the simple interest formula and just solve for T. Now remember, anytime I'm solving, I'm just trying to isolate the specified variable. So I'm going to treat the other situation just like I would treat a situation that included numbers with just one variable. So again, my goal is to isolate T. So get T by itself. And right now, I have T that is being multiplied by P and R. So to get rid of the P and the R, to remove them from T, I would need to perform the inverse operation of multiplication, which is division. So I'm just going to divide both sides by PR. And once I divide by PR, on the left-hand side, I should be left with just I, and I'm going to write it with a capital so it doesn't look like a 1, divided by P times R, equal to those two. P divided by P is 1 and R divided by R is 1, so we're just left with T. And since T is isolated, this is the solution to this example. This gives us the formula for the future maturity value invested for T years at an annual interest rate. So A here stands for the future or maturity value. P stands for the variable in dollars. R is the simple interest rate, and T is the variable in years. Again, T is in years. So I'm not finding the interest rate here, I'm finding the future value of the amount that I invest or borrow. So looking at this equation, I want to solve it for P, which is my principal, or the amount that I start with. And right now, looking at this equation, I've got P times the quantity, 1 plus RT. Since I was asked to solve for P, my goal is to isolate P. So all I need to do is divide by 1 plus RT on either side, because division is the inverse operation of multiplication. So now, having done that, I should be left with A divided by the quantity 1 plus RT equals, now, since I have only multiplicated things on top and on bottom, P times this quantity, I can go ahead and divide 1 plus RT by 1 plus RT to be left with just P. And since P is in isolation, this is my solution. Alright, I have an equation here that has more than one variable, and in this instance they have asked me to solve for the x. So my goal is to isolate x. So I'm going to solve it just like I would start any other problem. Since x is inside this parentheses, I'm going to have to distribute. So that will be my first task, to distribute the 3 to the 2x and the negative 5a. So the result after distributing My 3 is this. And so now my next task will be to get my like terms together, if any exist. And I notice that I have a 4x and a 6x. So I'll do that first. Next, now I chose to move the 6x to this side because I'm trying to isolate x, and already x is almost by itself over here. So that's why I chose to move 6 to this side instead of vice versa. It's going to save me a little bit of time. So now I just need to get rid of this 2, and I add it to both sides. Now since neither 15a or 4b, negative 15a, are like terms with 2, then the result of the left side is this. And so now all that remains is to divide everything by negative 2. So I've divided each term in the numerator by the negative 2, and the result is the following trinomial, which is equal to x. Alright, so this brings us to an example of calculating and actually applying the simple interest formula that we discussed just a moment ago. This is Megan borrowed $5,240 for new furniture. She will pay it off in 11 months at an annual simple interest rate of 4.5%. And so this is the clue that tells you, hey, use a simple interest formula. How much interest will she pay? So I know I'm going to use the simple interest formula. I equals P R and T. And I'm looking for the interest because that's what they've asked me to find. The principal is the amount borrowed, which is $5,240. The time is 11 months, but remember I'm going to have to transform that into years. So 11 months would be 11/12 of a year. And the interest rate is 4.5%, or 0.045 for our R. And this was T. So now we're just going to take those 3 values and plug them into our formula. So now the values are plugged into my formula. So all I have to do is multiply for the solution. And once I do that, I should get I equals 216.15 cents. So I would need to write my final answer as Megan will pay $216.15 in interest on her purchase. And so that will end the video, and I will leave you with an interesting yet useless fact. Cranberries, you know that you make cranberry sauce out of, and cranberry juice and cranapple juice, my personal favorite. But cranberries are sorted for ripeness by bouncing them. A fully ripened cranberry can be dribbled like a basketball. And so if I ask you tomorrow about the interesting fact, be ready to answer.